Hello and welcome to the E-Mobility Innovation Podcast, the podcast on e-mobility for research and industry. My name is Simon Voss, and in the coming episodes I'm delighted to provide insights on discussions I had with leading experts on the field of e-mobility at the E-Mobility Production Days hosted by PEM of RWTH Aachen. What's the status of innovation and where are we headed? Let's find out. Your area of expertise is compressors, so located in the auxiliary equipment sector. So can you just give us an outline of why we are talking about this and why it's such an important topic?
Yeah, absolutely. So fundamentally, when you remove an engine from a vehicle, people's primary focus is on batteries, fuel cells, drivetrain. But the next step of that, and what you can't go ahead with a vehicle without, is having all the ancillary systems, so pumps, fans. But for us, and what we do at Ingersoll Rand is e-compressors, so that's compressed air for braking and suspension.
Yeah.
And as you rightly said, really the market in which we're focused is the heavy duty and commercial vehicle markets. So trucks, medium duty and heavy duty trucks and buses. And as you say, we're seeing growth and new opportunity also in the off-highway sector. So things like cranes, wheel loaders, excavators. I think when people think about braking, they often think about passenger vehicles and they use either sort of electronic braking or more commonly like hydraulic braking, so drive-by-wire hydraulics. Larger vehicles, so your sort of your buses and trucks, especially where you have a higher curb weight, they tend to use pneumatic braking. So they're using pneumatic compressed air in cylinders to actuate the braking system on those vehicles. The reason they do that historically is for a number of reasons, but primarily one, you get a greater braking force with pneumatics. So where you need that higher braking force, pneumatics can offer that, and they offer usually a bit faster actuation of the braking than with hydraulics. There's also a real big discussion around wear of components. So with a hydraulic system, you have a limit based on the hydraulic fluid, and if you have a leak or you have high wear, the efficiency of that system degrades over time.
Okay.
And you can't have a situation where you have a heavy-duty, high-weight vehicle with degraded braking over its life. So pneumatics is a much more robust and reliable solution than hydraulics in that field. What we're dealing with now and what we do with Ingersoll Rand is we take that approach, the pneumatic requirement of the vehicle to brake and for suspension also for air bellows.
Yeah.
And we're now designing e-compressors. So these are compressors designed specifically for use in a zero emissions vehicle where you don't have an engine. Essentially what we're doing is we're taking a really simplistic system which people are very comfortable with and a mechanical system or a larger mechanical system, and we're suddenly replacing it with a much more complex electromechanical system which has its own requirements for control and software, has its own maintenance requirements and lots of specific requirements around installation on the vehicle. Where do you put this new machine? Because it's no longer connected to the engine in the same way. So integration is something that's much more challenging, and it requires the OEM and the OEM and the Tier 1 to be much more collaborative and work together.
Okay.
And that's what we've had to do as a business, is develop to that, to be more collaborative, which historically wasn't so much an issue.
But if it's so complex, why would I change?
You could run a piston machine in the same way. Piston machines have a number of issues, but primarily noise. So when you remove a diesel engine, the next loudest item on the vehicle often is the compressor, particularly piston machines. You want the passenger experience, but also the pedestrian experience in these vehicles to be better. And when you take away the engine, the compressor is suddenly the noisy part.
Yeah.
As well as that, historically these things ran 100%, and if you connect a compressor to the traction motor, it will perhaps run, but it's going to run the entire time the vehicle is running also. And you don't need that air, so you're using energy, often 2 or 3 kilowatts of energy, to run a compressor for air that you don't need. So people want to go to a stop-start solution, so you can turn the compressor on and off as you need it, you can move the speed around, and then you're getting a much more efficient use of your battery or your fuel cell.
Yeah.
But unfortunately, the sort of side of that comes into it, the complexity, is that then you have a system which needs bespoke control.
What else do you see on the horizon in the shift towards full electrification of vehicles?
I think auxiliaries are a very interesting topic, and that's why we're glad to be talking today, really, is because it's historically people start and they look and they take the engine away and they say, right, we start with the critical drivetrain. And ancillaries are always a secondary or tertiary discussion. And actually they offer a huge amount of opportunity for optimization if you use them less and less. And
if you don't have all this energy waste, right? Like
Exactly.
the compressor's running on the side without usage.
This is it. And you know, if you take also power steering, you know, electrifying a system, having in-wheel drive, this type of thing, mitigates the need for it. So you need either less of it or don't need it at all. And you know, the same certainly for compressors. You know, we're seeing regenerative braking changing how people need to run compressors today. So we need less flow and we need it to be more infrequently operated.
So you can downsize as well.
Absolutely. And then you know that extends into things like coolant pumps and fans. You can give different cooling supply. You can change the temperature profile in bespoke components. These aren't things we necessarily work with at Ingersoll Rand, but ancillary systems are the next logical step in optimizing the vehicle, and they allow us to really improve the system, not just in terms of taking away a parasitic load, but also about overall making the system more efficient.
Yeah,
and there's also safety elements. You know, traditionally we have a lot of hydraulic systems on vehicles, but hydraulic systems come with hydraulic fluid, comes with a fire risk and a leak risk. They are a wear part. You know, likewise, if you're using a lot of high voltage power and you have a lot of high voltage cabling, you have inherent risk to the individuals. But pneumatics can be often a safer approach. And again, if you can start to downgrade the size of these machines, to derate them to be more efficient for what they actually need to operate at, and part of that is legislation driven as well, then we can start to also improve safety. So ancillary is often overlooked, but there is a huge scope of things we can do with them.
Great, Greg. Thank you very much for the insights that we provide.
Great, thank you.